All right, top of the hour. So we're gonna get started promptly today. Good morning and welcome to our September Learning Series seminar, presented online by the Reynolds Company team. And today is going to be a power and drives update.
So yeah, the 755 TS is actually it's an enhanced drive over the 753s and some of the features of the old 755s. I don't want to say old because they're all still new. Sorry about the sound issue. Just had a little button here I forgot to click, but so the 755 TS does offer some additional functionality, like this screen showed, as far as safety, scalability, and security, some advancements in security that I'll go over. One thing where this 755 TS does add is the old frame 8, which was up to 400 horsepower in the 755 family. We also we have a frame 7A now. It's been requested for packaging, put inside of enclosures. Does make things a lot nicer as far as packaging and engineered projects. Does also have predictive maintenance in the total force that we talked about. The center image there is actually the old frame 8, which would have been the 755 offering, and we jump up to the new advancement is the 7A frame, which is the smaller frame on the right. This package, instead of going only to 400 horsepower in that smaller frame, we go to 450 and also 500 horsepower up to 617 amps. So I know the market has been asking for this. This has been a long time coming, and very welcomed to a lot of our customers, and especially our package solution providers. This is what it looks like in that family. This again is a 755, 755T S. This is what it would look like. So if you put it on the end of that, instead of jumping to a frame 8, which is the center image, the larger image, we've got the 7A frame. You can see the dimensions there. It's almost half the depth, 2/3 of the width. And if you look at the height there, it's about half of the height as well. So we go from a floor mount frame 8 to now a wall mount or an enclosure type mount frame 7A. And again, this is a 755 TS family. The conduit box, it's still being worked on, still being released. The whole intention of this drive being released was to put in packages, enclosures, other things like that. So this is still being worked on as far as the conduit box. The conduit box will eventually be out, I'm sure, very, very soon. But just to give you a heads up on that is coming. Some of the things that the 755 TS offer, I had mentioned earlier, like SIP security. We meet the IEC, the 443 rather, XT corrosion resistance, some enhancements in as far as the device logics, Studio 5000 as far as controlling this drive to more precise torque, especially. Speed is not so much an issue. And then we also, with this 755 TS drive, we do have a dual port gigabit Ethernet. The old 755, I keep calling it old, it's still a new product. The 755 on its own had a single port Ethernet, but this one is now a gigabyte or 1,000 megabytes. And it's a dual port. So that will have a dual port. The 755 TS does have one input. It's an enable. So if you want to use an enable and then run everything else through Ethernet, or you can add I/O cards, you can add encoder cards, power supply cards, anything. All of these drives through the 753 all the way through the 755 TS, TL family, they do use the same I/O cards. All of the same option cards fit into all these drives, including the HIM module. So it's very, you don't have to end up inventorying a lot of different components as far as I/O cards. This is kind of how it looks in the family. Again, I kind of flipped this around. This is a 6 pulse drive. Just keep that in mind. And if you want to jump up to the active front end drives to meet that IEEE 519, there's multiple ways we can do that. Obviously, jumping up to the 755 TL. There's other different ways by using filtering, other stuff that we can do with that too. Some of the added features with this, we've taken predictive maintenance to another level. Years ago, we used to use a battery in the drive, which would track the life, and then you could sound an alarm, or you put up on your panel view that it's time to change the fans out. This actually is starting to take drives to another level. Like with fans, for example, we know the physics and the characteristics of that fan, the life cycle of that fan, how long it will last, how long the bearings. I mean, that is textbook stuff that we can actually program into these drives to actually monitor. And when it's time to proactively change the fan out, we can do that. Also, like with capacitors and the IGBTs, those are more so temperature driven. This drive also monitors some of that as well to prevent or predict downtimes. This is a little bit on what it's actually looking at. The 755 TS, I shouldn't say just the TS. Again, the TL and the 6000 series do have this total force technology, which also includes this predictive maintenance. But some of the things we look at, like our current, the drive actually monitors the current and the temperature. Obviously, if the current goes up, the temperature is going to change and things like that. It actually does track that information, and it also helps us predict the life of that IGBT. To prevent downtime. That's the main thing. This is kind of how it does it here. It's if you look at a load observer, the first thing we would do is have, in the past, we always use auto tuning. This is just an advancement in auto tuning. Load observer, if you look, that is actually you're tuning the drive unloaded. It's actually takes that data, stores it in as far as the baseline of what this drive is supposed to do, with the baseline of what the current feedback and any kind of ripple coming back on the current to the drive. It stores that data as kind of the perfect run situation. As I said, unloaded. Adaptive tuning, that this goes up and beyond the preventative maintenance. This adaptive tuning is actually Rockwell kind of relates it to more of an AI drive. I was in Cleveland years ago, and they were first talking about this. And adaptive tuning, if you look, that is actually done through. When you load the drive, the motor is loaded, you're running your application. If you have any kind of noise or resonance type situations in the process, it will actually tune itself, and it will store that information. And it basically takes place of the old, if you had skip frequencies, for example. Years ago, we used to have skip frequencies. Now we can do away with skip frequencies with this adaptive tuning feature. This is another example of some of the things that adaptive tuning looks at. If you have a resonant or a mechanical issue, one thing to notice about this, Rockwell has taken these drives to a new level. Obviously everybody was up on controlling torque, controlling speed. Rockwell can also get down and control torque to 100% at 0 speed with these drives, with the 755. The 755 family does work with inductive, synchronous, and permanent magnet. The permanent magnet motor can be used with the 755 family across the board, with the exception of the PowerFlex 6000, the medium voltage. If you have one of those applications, we can talk about that. But they've taken these drives to a whole new level. And the main thing is longevity of the whole system. So if you're looking at the mechanics of a process, you've got a conveyor. In this case, it's I know we're in the oil and gas industry, but it shows like a paper mill. You can control torque, inertia, and also if there's different changes in an inertia, for some reason due to mechanics, the adaptive tuning feature will and can actually tune that out to keep that process going smoother. And again, our main thing is with the 755 TS, and what Rockwell is doing here is helping maintain your whole system and the life of your system. So it's just not the drive. We want to maintain the life of the motor, extend the life of the motor. We want to extend the life of the whole process as far as the mechanical end of everything. So again, that's the main thing behind this adaptive tuning and our advancement kind of over the competition there. This is just another example. This is just a swaying load. Again, I know it's kind of if you got a pump, let's just say a pump in the oil and gas industry, and the pump cavitates, we can back out of that so the pump stops cavitating. That's just another example. But this is an example of if you have a bottling line. I know we do have some food process, especially in Dallas. We've even got some down here in Houston. But if you've got bottles that are moving on a conveyor, we can tune that drive, and instead of going back and detuning, which that used to be the old way of doing it, the adaptive tuning can actually take care of that for you, because the detuning of a drive used to be a pretty big deal. You had to spend a lot of time doing that. With this new adaptive tuning, when it's implemented properly, will help you with that. Security and safety. This is where we start getting into like the SIP security. We do have some products out. Security is more so to I don't want to say create a firewall. It's not really a firewall, but it's we can actually check authentication for anything trying to come into the communications on the drive. This is through communications. We do have some encryption and other things that take place for the security of a network to prevent cyber attacks, different things like that. This is an example of the some of the safety cards we do have. We do have safe torque off, safe stop, safe speed. We also do have, I don't know if you all are familiar with the safe torque off. If you have a situation where you need to release the drive, you can do that. Or maybe a leak in a pipeline or something like that. In safe speed, we can drop down to a safe speed to control, so we can keep the process going and keep the flow going. We also have the new S3 and S4 cards. These are safety cards over Ethernet that we can also do that same function as far as safe stop, safe speed, and safe torque off over Ethernet. It does require the guard logics. When you start implementing some of these safety cards at this level, you do have to implement a guard logics into that, like the 5380 ES controllers there. It does meet the SEAL2 and SEAL3 as far as the safety probability of any events from happening. This is this shows you just an example. I don't want to say a 10,000 foot level, but this is basically, we can implement safety in all of our products. So the drive can actually be part of that through one of the switches there. As you see, the Stratic switch. We do have other safety products in there, so it can be a complete safety package. If you have a real critical situation or a dangerous situation in an application, the drives can be implemented into that whole process. So that's just showing we do have other packages, other safety devices that we can implement or design into that system as well. This is the XT. If you see, we'll start getting into some of the corrosion resistance products here. We do have, if you look over on the left, all of those all of those products or those option cards. They do have an XT in the end of them. We do have them without the XT as well. We're going to be going through the XT, the safety or the as far as the environmental stuff here shortly. But we do have them with and without the additional corrosion resistance. That's just to give you an example there. The two up top that we do have an additional power supply, which you can put into a drive to slightly prolongs the ride through in case you have a brownout, or if you have a situation where the power goes out, you can bring the drive back online and do an auto start much quicker. That's with that second item down, the auxiliary power supply. The T-Link is actually, the top item there is actually a peer-to-peer communications. So you can high-speed communications, so you can basically synchronize two drives to almost real time. I don't want to say 100% real time, but nothing's 100%. But you can synchronize two or more drives linked together, and that's actually a fiber optic link that links all the drives that you're looking at doing. There's a limitation on the number of drives, but again, if you have an application like that, you can call in your salesperson or one of us to assist with that. This is where we get into the corrosion resistance, and the corrosion resistance started coming into the family with the 755 TS offering, which originally was a TS XT. If you look down on this drive, it's got an XT in the bottom of it. We do have test validations that Rockwell has ran, and they do have a system. I believe it's up in Wisconsin, which is, I think, one of the only ones available in the United States right now. And they do like a 30-day exposure, but it's actually to a certain method they use for gases. And the 30-day exposure actually compares out to like a 10 or 12-year corrosion type situation. So it does monitor, not monitor, it does protect, critical connections. There's some other things we can do with that. Also the components within a drive. This is just an example of the extreme environment protection that we offer. If you see on the right there, the GX, for those of you that are familiar with it, the GX and C, it's the ISA 7103, and the other one there is the 6721, as far as the corrosion resistance testing and stuff that's done on that. This is what you'd actually see, like on the left there, maybe after so many years in a highly gaseous, corrosive type environment. These are dendrites. These are actually like crystallizations. A lot of people, you look at them and you think they're a fungus, but they're actually, the crystallization will actually eat through and get down to the board level and start eating at the components. Be it just the board level stuff or even the IGBTs. If you look over to the right there, that would be a 10-year cycle. That just an example of a 10-year cycle, approximately 10 years, with our XT coating, additional coating that is on those boards. So it's just an enhancement of what we've had before as far as the board level type protection. And the main thing I want to end with, I always like to show this, but sometimes I usually put it in the middle. I know most of you have seen this. Some of you out there are probably thinking, "Oh my God, this again!" But all of our drives will work with the automatic device configuration. And the main thing to remember is, if you have a drive fail, if you replace that drive with the drive in the same frame size. So if you have a 755 TS, maybe a 20 horsepower, as long as you replace it in the same frame size, it doesn't have to be an exact 20 horsepower, but in the frame size so it will physically fit into that area, you can actually pull that drive out. It does require the control logics connectivity. The control logics actually holds the program. The drive holds its own program as well. You can also hold the program in the HIM module. So there's multiple places, so you don't get stuck with downtime to where you need to have somebody come in, late at night, early in the morning, and reprogram these drives and figure out the whole application again, reset the IP address. So it does when that drive fails, you basically remove the drive, install a new drive, again of any frame size, or that frame size, that specific frame size, and then it automatically loads the IP address, the firmware, flashes the firmware, and the configuration is flashed back to that drive. So basically you're up and running, and the only thing you had to do is install the drive and basically boot the system up, which the control logics will identify a new drive in that position, and then you're back up and running. So that's all I have for today. I appreciate you letting me present. Also apologize for the initial voice issue, but with that, I'll hand it back to you all. Thank you.
All right, thanks, Mike. And now we'll turn over to Sheila.
So Mike shared with you all information about our drives, our offerings, and the drives that we have in our product portfolio. I will now talk about Guardian AI, and introduce what Guardian AI is and how it works alongside with our PowerFlex 755 drives. So Guardian AI, how it came about is that Rockwell noticed that our customers have two methods in which they do their predictive maintenance or their maintenance planning. And one is a reactive approach where a system or machine goes down and they're forced to do maintenance on the machine to get it back up and running. And the other is a proactive approach where they have regularly scheduled maintenance. So maybe on a quarterly, weekly, monthly basis, they take a system or machine down and do maintenance on it, which could sometimes lead to unnecessary downtime because the system may not necessarily need to go down, but since they're doing a proactive maintenance approach, they take it down anyways. As a result of that, we came out with Guardian AI, which is a predictive maintenance solution that it monitors the system in the background and then gives you some alerts when any types of failures come. And what the results of that is that it would help to increase your production because you will only be doing maintenance when it's required, as well as cost savings. So you won't have to have any of the unplanned downtime or any downtime that's not necessary. So here with FactoryTalk Guardian AI, these are the 4 key areas where we feel like Guardian AI sets us apart in the predictive maintenance space with our competitors. The first being that your devices. So with Guardian AI, you're going to be able to use your existing devices as sensors, and these existing devices are our PowerFlex drives. We have certain drives that are compatible today with Guardian AI. So unlike competitors where you would have to purchase additional devices to do some of that predictive maintenance, there's no additional purchase of sensors for Guardian AI. Additionally, it is designed specifically for our maintenance teams. So there is no data scientist needed to do any type of machine learning in the background. It's easy for the maintenance teams to deploy it, get it set up, and start monitoring these systems. It's not just anomaly detection, but it's also anomaly identification. So there are recommended solutions or applications in this first release that we are recommending that you run Guardian AI with, and those are pumps, fans, and blowers. And if you are using one of these recommended applications, then there are already some predefined faults that we call the first principle faults that will be able to shoot out a synopsis of what the issue is. And then additionally, this is all done at the edge. So Guardian AI is a piece of software that runs at the edge. So it sits on an edge device and it communicates to the asset, and you are able to get the real-time data. So from a high level overview, these are the components of what the architecture of a Guardian AI system would look like. So as I mentioned, the recommended assets are pumps, fans, and blowers, and these are controlled by our PowerFlex drives. And so what Guardian AI does is basically it's monitoring the electrical signal analysis from the drives of those assets. And then anytime that it notices any sort of deviation from normal operation, the software, which again is on the edge device, will send out an alert to the user. Today, these alerts are through email. And so the user would get an alert from an email, and it would, if it's a first principle fault, then it would output what the fault is, and then the user can then go and check the system, correct it, and then come back into the software and acknowledge that that was the fault and that it's back to normal conditions. And then Guardian AI will continue to monitor the health of that asset again until any other deviation comes up. So as I mentioned, our drives are what we're using as the sensor. And so here, this is just an overview of the drives that we have out today that are compatible with Guardian AI. So our 755 drives, the TL, the TR, and the TM drives that are in the 755 family, as well as the 755 TS drive. And then if you are doing any type of medium voltage and you're using the 6000T drive, that drive is also compatible with Guardian AI. So you can get the software and set up the Guardian AI application if you are using these. And as I mentioned, so there's no data scientist required. It's designed specifically for our maintenance team, and there's really 4 simple workflows for setting up and configuring the Guardian AI solution. So the first step is to complete that initial setup. And so that initial setup, what that consists of is installing the software. So as I mentioned, the software it sits on the edge. So this can be on a Rockwell edge device, or this could be on a third-party edge device that has the recommended operating systems and parameters, or you can also run it on a Linux virtual machine. Once you have installed the software, you would then identify what type of asset it'll be monitoring, whether it's a pump, fan, or blower, and you'll establish some of the baseline behavior. So that is putting in the normal operating procedures, the frequency that the system will run at, as far as 20 hertz to 40 hertz. And then once you've established that baseline, then it will start training. So in that training process, it will train at every half hertz. So as I mentioned, if it's 20 to 40, it'll train at 20, 20.5, 21, 21.5, and so on and so forth. Once it's done training, then it will go into the monitoring. So that's step 3. So in monitoring, it'll automatically transition into monitoring after training, and that's all done in the background. So your asset is in normal operations, and it's monitoring the health of the asset. And then at any point, if the software notices any deviation from the normal operation, that is when the user will get an alert through email. And so that alert will come in, and then there are 2 different ways in which this anomaly identification is done. We have first the embedded expertise. So once this alert comes in, if it is one of the first principal faults, and what you can see on the right-hand side, these are some of the first principal faults that you might have on these pumps, fans, or blowers. So maybe blade fault, motor fault, if you might have any type of cavitation on the pump. These are faults that will automatically be outputted in Guardian AI, so letting the user know that, hey, there's a blade fault. So you go and check it out, confirm, resolve the issue, and then it continues on into monitoring. The second form of identification is user classification. So what user classification is if the software notices that there's a deviation in the normal operation, they have the baseline, but they don't know exactly what the fault is because it's outside of the first principal fault, then it will alert the user that the asset is running outside of the normal operation, and the user will then go to the asset and do some troubleshooting to determine what the fault is. Once they've determined what that fault is, then and resolve the issue, you can then come back into the Guardian AI software and you label that fault. So now the fault is labeled and Guardian AI knows what that fault is. So it'll go back into the monitoring mode. And then anytime it sees that same deviation, it now knows what the fault is. So it'll be able to output that fault. So as you continue to use Guardian AI and you continue to, label faults that are not known to the software, it continues to get smarter and smarter and can help with predicting any type of upcoming failures and faults. Here, this is an overview of the components again. So on the right-hand side, you'll see at the plant floor, this will be your pumps, fans, blowers, are your motors. Then you have the PowerFlex drives, the ones that are compatible with Guardian AI today, which are connected to those assets. So the drive is then connected to Guardian AI, and this connection is done through the Ethernet IP address of the PowerFlex drive. So this connection can be direct from the drive to the edge device, or it can be through Ethernet. An Ethernet module that's in the back plane, so it can go through the back plane through the Ethernet module and then to the edge device. And as I mentioned today, as far as alerts, the alerts are all done through email. In a later release of Guardian AI, these alerts will also be able to write back to the controller. So through the back plane, it can write to the controller, which will allow for you to be able to then get those alerts up into an HMI. And so that's the components of a Guardian AI, or the architecture of a Guardian AI system. And then as far as the deployment, there are two methods in which you can deploy the license or the application of Guardian AI. And those two methods are either through FactoryTalk Edge Manager, which is Rockwell's edge management solution that sits inside of the cloud, FactoryTalk Hub. That'll give you the ability to deploy a container-based application of Guardian AI to the edge device, an edge manager compatible device, or you can do the manual deployment, which would just be manually installing and deploying the application to your edge device. So I mentioned two methods in which you can deploy the application. So here, these are just highlighting the minimum hardware specifications. So one instance of the Guardian AI license or the Guardian AI software gives you the ability to connect to 10 drives. So with that one license, you can connect and monitor 10 drives or 10 different assets. If you were to use Edge Manager as your deployment mechanism, the minimum specifications for the hardware, of course, would be an Edge Manager node that has the Intel Atom 4 core, 8 gigabytes of RAM, and 120 gigabytes of solid state drive, as well as the Edge operating system, the EVOS. So from a Rockwell standpoint, the Rockwell compatible hardware for this would be the 6300B Edge computer. This is the awesome 6300 Edge compatible device that Rockwell has that you can provide. From a third-party standpoint, if you already have your own Edge device that you would like to use Edge Manager to do that Edge deployment, Rockwell can go through the process of certifying the Edge node to be able to make it Edge compatible. And then from a manual installation piece, so if you're not using Edge Manager, then as far as the processor and the minimum hardware, those specifications are the same, but operating system, again, it needs to be a Linux operating system, Debian 11 or 12. And from a Rockwell standpoint, the recommended Rockwell device would be the 6300B box PC. Or from a third-party standpoint, any third-party device that meets these minimum requirements. And then, of course, if you're using a virtual machine, of course, that host operating system for the virtual machine would also need to be a Linux Debian 11 or 12. This slide just kind of wanted to really quickly, because we kind of commonly get this question sometimes. What's the difference between Guardian AI and Total Force technology? So if you are aware and you're using our current PowerFlex drives today, there is a technology inside of the PowerFlex drives known as Total Force technology. And what the Total Force technology does, really, this is a predictive maintenance solution that really monitors the health of the drive. So it's able to identify you in of any faults that might be like blown fuses or any issues with the component runtimes and things of that nature, whereas Guardian AI is monitoring the actual asset, so the pump, the fan, the blower. And so with Guardian AI, again, it will identify any things like cavitation, blade misalignment, blade faults, and things of that nature. So the combination of the two, both the Total Force technology and the Guardian AI software, really gives you a complete system health, right? So you'll be able to get the health of both your drive that is controlling these assets, as well as the health of the assets, and be able to really maximize on your predictive maintenance solution. And then lastly, in regards to Guardian AI, as I mentioned, so today, the 755 and the TS to TL-TM drives, as well as the 6000T, are the drives that are compatible with Guardian AI today. But in later releases of Guardian AI, we will also be incorporating additional drives into the portfolio that will allow Guardian AI to work with them to be compatible. We'll also be incorporating E300s into Guardian AI, so you'll be able to use the E300s and Guardian AI together to do some predictive maintenance, along with vibration monitoring. So if you have any of our vibration monitoring devices, that'll soon be incorporated into Guardian AI. And then lastly, iTracks and kinetics. So if you're using any kinetics drives, there will be a point where those will also be integrated into Guardian AI. So with that being said, that is all for Guardian AI, but did just want to a little teaser, or just to bring this up. If you have been following along with our SaaS offerings in Factory Talk Hub, you may be aware that we have Factory Talk Design Studio that's available in the hub as well. And this is really a cloud-based design environment for you to build out some of your projects and applications. Now, IntelliCenter, so if you're familiar with IntelliCenter, this is a pre-configured software package that really gives you the ability to visualize and customize your MCCs if you have an MCC lineup. Now we have a version of IntelliCenter that is also integrated into Factory Talk Design Studio inside of the cloud. So previously, we've only had the on-prem version, which is a full feature set. Now we have the cloud version, and what the cloud version is, it is not a full feature set, it's a foundational feature set. And today, what it provides is the offline functionalities for you to be able to show the elevation view, have the MCC documentation, as well as integrate some MCC devices to controllers. What that looks like today at general availability, what it looks like is inside of Factory Talk Design Studio, really you just have the ability to do the design piece of it from the IntelliCenter, not the operate and maintain. So if you're needing to still do some of that operate and maintain, that will require the on-prem version of IntelliCenter software. But if you do some of that designing inside of the Design Studio, there is the ability, you do have the ability to export that. And then once you export that, you can integrate it into the on-prem version of version 6 of IntelliCenter and be able to operate and maintain your MCC. And this is available today to test out. So if you haven't seen it or tried it out yet, you can try it out and you can get access to Factory Talk Design Studio, just going to our Factory Talk Design Studio website, our Factory Talk Hub and signing up for the trial version or to be able to test out Factory Talk Design Studio. Right now, there is no cost associated with it. And if you have any additional questions in regards to IntelliCenter or Design Studios, just let the team know and we can, get those questions answered or get feedback for you.